Alright, problem number 3. We have this square with a circle inscribed in it, and then we have a square inscribed in that circle. And we're told that the radius of the circle is 10 centimeters. And the question is, what is the area in square centimeters of the region between the two squares? So we're talking about, all this region here. I suppose I could highlight it for you. I'm guessing you probably can guess what it is, but it's essentially this region here, if I can get it highlighted. Anyway, it's not very straight, but you know what I mean. It's this thing here. Alright? So, alright. So, let's see what we can figure out. Alright, we're given the radius of the circle is 10 centimeters. Alright, so if I draw the center of the circle somewhere about there, then I know the distance from that point to any point on this circle is 10 centimeters. So I can actually draw a radius that goes out here to this corner of the square, okay? Because that square is touching the circle at the corner, all right? And I can also draw a radius over here to that corner, okay? So the radius of the circle is the same as this line to the corner of the circle. And you can see that I could do that with any of these corners. I can't draw very straight lines, but so essentially what we have is two diagonals of the square. All right, and those are all those lines are radiuses. So the diameter of the circle is equal to the diagonal of the square. All right, and we know that's 10. So the radius is 10. So we could mark this. This is 10. This is 10. 10, 10, alright? And we also know, because this is a square, and so the diagonals are going to meet at a right angle here, and it's going to be a 45, 45, 90 triangle, okay? So this is 45 degrees, and this is 45 degrees, okay? So it's an isosceles right triangle. And we know two of the sides of this triangle, of any one of these triangles actually, but so we know two of the sides, and we know it's a right angle, so we can find the hypotenuse using the Pythagorean theorem, right? So the Pythagorean theorem says that the square of the hypotenuse is equal to the square of the two sides, the sum of the squares of the two sides, right? Alright, so in this case the hypotenuse here is C, and we'll call this A, and this is B. Okay, so A is 10, B is 10, and now we can find C, right? All we have to do is square those sides, so we get 10 squared plus 10 squared, and that's going to be equal to 200, right? And we know that's equal to the hypotenuse squared. Alright, so we can find the length of one of the sides of the squares, and we know that the square of that length is the area, so this is also the area. Let's write it down here. This is also the area of the small square. Okay. Alright, so we have the area of the small square, and we need the area of the big square. And then if we have the area of the big square, we can just subtract out the area of the small square, and then we'll have this shaded area. We'll have the area between the two squares. So let's draw another radius. All we know is the radius of this circle, but we can also draw a radius here, right? We can draw a radius here. So essentially the width of the square is equal to the diameter of the circle, right? So if this is 10, whoops, 10, and this is 10, so the width of the square is 20, and it's a square, so that's also equal to this dimension, right? So it's a 20 by 20 square. So what's the area of the outer square? The area of the large square is equal to 20 times 20, which is 400 square centimeters, right? All right, well then we have it. We've got 400 for the large square and 200 for the small square. So we're left with 200 square centimeters for the area between them, right? We just took the outside area and subtracted the inside area, and then we have it. So there you go. The area between the two squares is 200 square centimeters.